Section 9.3 is titled Multiplying and Dividing Monomials. So by the end of this lesson, we want to be able to do just that, multiply and divide monomials. The first property I want to discuss is the product of powers property. This states that when you multiply powers with the same base, we want to add their exponents. So if you have a to the m power times a to the n power, remember the base, the a, these are the same, then we want to add their exponents, m plus n. So if we look at the examples, we have 6 to the 7th times 6 to the 9th. So we add the exponents and get 6 to the 16th, 7 plus 9. In the second example, 2 to the 2nd times 2 to the 4th. That gives us 2 to the 6th. 2 plus 4 is 6. And I'll show you in that example why this works. Let's think about what 2 squared is. Remember that 2 squared is 2 times 2. And 2 to the 4th is 2 times 2 times 2 times 2. But we're multiplying those together, so now we have 2 to the 1, 2, 3, 4, 5, 6. 2 to the 6th. So that's why the adding works. So let's find each product and express using exponents. What that means is that you don't have to give me an actual numerical value, we just have to apply the product of powers property. So we're going to take 4 to the 3rd times 4 to the 5th. We're going to add the 3 plus 5 and get 4 to the 8th. Number 2, we have 6 times 6 to the 4th. And remember when we discussed that when you don't see an exponent, it's an implied 1. So we have 6 to the 1 plus 4, or 6 to the 5th power. We can also use this property with variables. Because the base is still the same, b and b, we simply add the exponents, b to the 4th. Number 4, we get y to the 9th. And again, remember why this works. What is y to the 6th? Well, that's 6 y's being multiplied together times 3 more y's being multiplied together. So if you add all those up, we get y to the 9th. A couple more examples, a little more complicated here because we have coefficients in front. So we have 2x to the 3rd times 8x to the 4th. Remember though that this itself is multiplication, 2 times x cubed. This is also multiplication, 8 times x to the 4th. Multiplication can be done in any order. So I could rewrite this and say 2 times 8 times x to the 3rd times x to the 4th. Now it's a little easier to see that when you have coefficients, those need multiplied together, 16. And now I have variables that have like bases, exponents on them, I need to add them, and I get 16x to the 7th. Try number 6 on your own using the same rules we just talked about. You don't have to write this step here, just remember what you're supposed to do with your coefficients. So pause the video and then check your answer. 5a squared times negative 3a to the 4th. Remember that parentheses indicate multiplication when there are no addition or subtraction signs in between. So 5 times negative 3 is a negative 15. We multiply the coefficients. And now we need to add the exponents on the variables. A squared a to the 4th, that's going to give me negative 15a to the 6th. So now we looked at the product of powers property, let's look at the quotient of powers property. And you may be able to come up with this on your own. If we're multiplying powers with the same base, we add the exponents. So now that we are dividing powers with the same base, we're going to subtract the exponents. In the example, we have 6 to the 7th over 6 to the 4th. Remember, a fraction bar means division. So we subtract the exponents, 7 minus 4, and it's always the top number minus the bottom number. it gives us 6 to the 3rd. And let's see why this works. Let me string out 6 to the 7th here. So we're multiplying 7 6s together on top, and on the bottom we're multiplying 4 6s together. Well, we know that with fractions, when we have a fraction, we can reduce, or we can do some canceling on the top and the bottom. So essentially what happens is every 6 on top can cancel with one of the 6s on the bottom until we're out of 6s somewhere. So you can see then that there are 3 left, and that's how we get 6 to the 3rd. Essentially what you're doing is you're canceling some of those factors of 6 on top with the factors of 6 on the bottom. So we subtract exponents. Let's look at some examples. Let's find each quotient, and again we're going to express using exponents, which means we don't actually have to evaluate the number. So 8 to the 5th divided by 8 to the 3rd is 8 to the 5 minus 3rd power, or 8 squared, 5 minus 3. Number 8, we have 3 to the 9th power over 3 to the 2nd power, so we're going to subtract 9 minus 2 and get 3 to the 7th power. And remember how big that number can get. It's 3 times 3 times 3, 7 times. Again, we can do the same thing with variables. We can apply the quotient of powers property simply by subtracting exponents as long as our bases are the same. And remember, the base is the number that has the exponent attached to it. So this would be c to the 7th over c to the 2nd. We subtract and get c to the 5th. Number 10, we have b to the 7th over b to the 6th. We subtract and get b to the 1st. And we don't have to write b to the 1st. We can just write b, because remember, when a variable is written with no exponent or a number is written with no exponent, it's an implied 1. So hopefully you understand the two properties for multiplying and dividing monomials. If not, you can rewatch the video or make sure that you're asking questions in class. We'll work on worksheet 9.3.